Forms of basic trigonometry. So let's start. What is basic trigonometry and what are the trigonometry we will discuss today. Let's see that. Let's draw a right triangle. This is right triangle EBC. This is the theta. So with respect to this angle theta, with respect to the angle theta, the height is equal to BB, base is equal to BC, and hypotenuse equal to AC. Sine theta inside sine theta is equal to height by hypotenuse AB by AC. Then cosine theta is equal toins of cos theta equal to base by height BC by AC. Then tangent theta, six trigonometric function, tan theta inside tan theta, height by base AB by BC. Then cotangent theta inside cot theta. This is equal to base by height BC by EB. Then secant theta inside sec theta, which is hypotenuse AC by base BC. And 4 secant theta inside cosec theta equal to hypotenuse AC by height EB. So these are the 6 trigonometric functions defined, and we have to learn about this. So what are the relations between these? Like if we go through sin square theta plus cos square theta. So sin square theta means BB square theta by AC square theta. Cos square theta is equal to BC square theta by AC square theta. So this will be AC square theta plus BC square theta. So if we now use Pythagoras theorem, this numerator will be equal to AC square theta. We know that height square plus base square is equal to hypotenuse square. This will be AC square by AC square. So this is equal to 1. So we have the relation that sin square theta plus cos square theta is equal to 1. So you have to remember this is the number one formula also. Now if we go, what will be sec square theta minus tan square theta? Sec square theta is equal to AC square by BC square minus tan square theta is AB square minus by BC square. So this will be the numerator, common numerator, denominator will be BC square. The numerator will be AC square minus BB square. Again by Pythagoras theorem we will have AC square by BC square is equal to 1. This is our second formula, that sec square theta minus tan square theta is equal to 1. Now the third one, what will be cosec square theta minus cot square theta? So again we will have AC square by AB square, and for cot this will be BC square by AB square. This will be AB square AC square minus BC square. So AC square minus BC square will be AB square again by Pythagoras theorem by AB square equal to 1. So this is our third formula, that cosec square theta minus cot square theta is equal to 1. Now if we verify, what will be tan theta multiply cot theta. So tan theta is given here AB by BC and cot theta is given BC by AB. If we multiply both these, BC cancels each other, AB cancels each other, we will get just 1. Fifth number formula is that sin theta multiply cosec theta is equal to, so sin theta is given AB by AC and cosec is given AC by AB. So again for these two, if we multiply, AC cancels each other and AB cancels each other, so we will get 1. And sixth number formula, cos theta multiply sec theta is equal to, cos theta is equal to BC by AC and sec theta is equal to AC by BC. So these two, and again BC cancels each other and AC cancels each other, so we will get just 1. So you have to remember this 6 formula also with these 6 trigonometric functions. Now if we used to know what will be the value of sine 30 degree and sine 60 degree, so how we could know these values, sine 60 degree and sine 60 degree? So here we have to take the equilateral triangle This is an equilateral triangle. Three sides are equal. All are equal to side A units. See A, B, C, and we will make a perpendicular from point A to BC. This is AB. Now BD will be A by 2. So we know that each angle is equal to 60 degree for an equilateral triangle. So this angle will be 30 degrees and this angle will be 60 degrees. Now the perpendicular forms a right triangle ABD. This is a right triangle. So we have to find out AD, the height of the perpendicular perpendicular length. AD will be 2 under root over by Pythagoras theorem A square minus A square by 4 means AB square minus BD square. So this will be root 3 by 2 into A. Now if we wish to know sin 60 degree, sin 60 degree is equal to height by hypotenuse. This will be AD by AB. So AD is root 3 by 2 into A and AB is equal to A. So we will have root 3 by 2. So this is the value of sin 60 degree, root 3 by 2, and sin 30 degree will be sin 30 will be with respect to this angle. This is the height BD and hypotenuse is AB. So this will be BD by AB. So BD is equal to A by 2 into 1 by A. So this will be 1 by 2. So this is the value of sin 30 degree and sin 60 degree. In this way we can find out sin 45 degree also. Sin 45, what is the value of sin 45 degree? If you wish to know, we will draw a right triangle. Where these two sides are equal, A, and so these angles will be 45 degree and this angle will be 45 degree. This is A, B, C. This is also a right triangle. So for this, AC will be under root over A square plus A square, AB square plus BC square under root over. So this will be A root 2. So sin 45 degree will be height AB, which is A, by AC, which is A root 2. This will be A by A root 2 divided to 1 by root 2. This is the value of sin 45 degree. Now if we wish to know what are the value of cos 30 degree, side cos 60 degree and cos 45 degree, so we can know this through these values by complementary angle. Like cos 60 degree will be equal to sin 30 degree by complementary angle. Sin 60 degree will be equal to cos 30 degree and sin 45 degree is equal to cos 45 degree. So in this way we can know the complementary angle. Through complementary angle we can know the value of cos 30 degree, cos 60 degree and sin 45 degree. If we know these values, then through these formulas we can know the tangent value of 30, 60, 40, cotangent, secant and cosecant. All these other trigonometric functions can be evaluated through these two, evaluating these two sine and cosine trigonometric functions. So in this way you can draw a table of values of 30 degree, 60 degree and 45 degree. So thanks for watching. If you like these videos, then like, share it with friends, and if you have not subscribed this channel, then subscribe.